Hello students, I welcome you to Mechanical Gate tutorials. Now we are solving previous year gate questions from Theory of Machines. Now this question is from mechanisms related to finding velocity and acceleration. Now the question is the crank of a slider crank mechanism rotates counterclockwise with a constant angular velocity omega. Assume the length of the crank is r. Using exact analysis, the acceleration of the slider in the y direction at the instant shown where the crank is parallel to x-axis is given by minus omega square r, 2 omega square r and minus 2 omega square r. So in the beginning when you see this question, it may look little difficult to get the solution, but we should not worry. Let's see the solution of this question. Okay, now now the length of the crank, this crank is making pure rotation. This crank is fixed here, so it is making pure rotation. uh, the length is given, that is r. This length is 1 and this is 1. The directions are given, y and x are given, so therefore the this sign minus and plus here we have to be very careful while marking the answer. Okay, now we can proceed with the velocity diagram and then the acceleration diagram. So let's see how we can get the velocity diagram for this particular mechanism. So I will give the notations. Let this point is O, OA is our crank, and let this slider is B. Now as per the question, we need to determine acceleration of B with respect to point O, that is the acceleration of the slider along positive y direction. So as the crank is rotating in the counterclockwise direction, the slider will move in the upward direction for the instant, right? So it will move in the positive y direction. So our answer is should be in the positive, either B or C. Okay, that is the first conclusion, but we have to check what is our exact solution. Okay, so let us draw the velocity diagram. Velocity diagram. Now you see the velocity of point A with respect to O will be perpendicular to the crank OA. So if I fix this point O here, the velocity of point A will be directed vertically upwards, that is perpendicular to OA. So this point is A. This point is A, right? Now also we know that the velocity of point A is r omega because it is making pure rotation. So V equal to omega r, right? Now the velocity of point B with respect to A will be perpendicular to link AB, or the velocity of A with respect to B will be perpendicular to link AB. So we can draw the locus, and this passes through point A. Now on this locus we have point B, right? Because point A is already there, then the velocity of B with respect to A will pass through point A perpendicular to link AB. So this line what I have drawn is perpendicular to OA. I am sorry, perpendicular to AB. It is perpendicular to link AB. Now the next is, if we see the velocity of B, that is the velocity of the slider with respect to fixed point, that is O, because B is the slider and it is sliding in the positive vertical direction. So it will be like this. So I will use some other color. So velocity of slider. Now this is the velocity of B with respect to O. So it is intersecting this line at the same point. So point A and point B coincide. So this is the the interesting point here. The point A and point B coincide. The meaning is the velocity of A is equal to velocity of B. The again conclusion is the relative velocity of B with respect to A, or A with respect to B, is 0. This is what we get from the uh, velocity diagram. The relative velocity of B with respect to A will be 0. Both have the same velocity for the given instant, for the given configuration. Another conclusion from this, the important is the radial component of acceleration of b with respect to a will also be 0. This comes from this, right? I'm not explaining in detail. This is the short explanation. Okay, this is the immediate conclusion. The radial component of b with respect to a is 0. This comes from this. Now this is coming from this, and this is clearly evident from the velocity diagram. Now we will proceed with the acceleration diagram. Now see, the acceleration of a with respect to o, since it is making pure rotation, it is fixed here. It will have only it will have the radial component, because we have to check here. It is given constant angular velocity. It is moving in the constant angular velocity. That means the tangential component will not be there. Only the radial component will exist. So therefore, acceleration of a with respect to o will be in this direction. This is acceleration of a, and this point is, I will write it as a dash. This point is o. So this is the radial component of a with respect to o, or simply it is a. Now what is the value of this? So I hope you can see this diagram. The value of this, this is the acceleration diagram. Okay, the value of this is omega square r, the radial component. AO is omega square r. This is also must be known to you. Okay, the radial component we can also find out like this. The radial component is v square by r. V is omega square r square, because v is r omega divided by r. So it is AR is r omega square. This is simple. So this is the representation of acceleration of a with respect to o. Now the acceleration of a with respect to b, or b with respect to a, since as you can see the radial component is 0, so it will have only tangential component. It will have only tangential component, and that will be perpendicular to link AO. So it will have the tangential component. Now this is AT of a with respect to b, right? So it will have tangential component. Now what is the angle? This angle is important. Now this angle, since the geometry is given as this distance is 1, this distance is 1, so this angle is 45 degree, or this angle is 45 degree. Therefore this angle is also 45 degree. This is important understanding here. The tangential component is making 45 degree with respect to the x-axis, or this acceleration line. Now the acceleration of slider, that is b, with respect to o, will be in the vertical direction. So it will move like this. This is the acceleration. Now this point is the locus of point b. This is also locus of point b. It is the intersection b dash. Now this distance is acceleration of b with respect to o, and that is what we have to find out. Okay, now see, in the, this is 90 degree, so this is just, you mathematically we can find out tan 45 degree. So if I write tan 45 here, it is opposite acceleration of b divided by adjacent, that is r omega square. Okay, so therefore acceleration of b acceleration of b is, that is the slider acceleration, is what option we have? The option C, that is omega square r. So now this is how we have solved the question. We should not be worried by seeing the configuration of the mechanism. Instead we should follow the fundamentals. Now let us start with the velocity diagram. What is the conclusion? So here is the conclusion. Now this is something clue or hint where we can draw the acceleration diagram and get the solution. So finally we should be happy that we could solve, and this is the right answer.